Hello everyone, and welcome to today's presentation about test automation. The topic of our today's discussion is how to avoid common mistakes and get the most value from your automation project. Before we start, let me say a few words why I decided to pick this topic. So in my professional experience, I've been encountering a lot of projects which are struggling with test automation, and they are having trouble either with maintenance or with getting value from it or with unstable tests, etc. And usually what I noticed is that people are repeating the same basic mistakes or are not following the common best practices for automation. And a lot of those troubles could be avoided if those people just knew about them and implemented them. So that's why I decided to share it with you today. So hopefully this will help you to avoid those mistakes in your projects, in your automation. So let me introduce myself. My name is Vlad, and I'm a .NET Automation Technical Lead at Cyclum. I have overall about 7 years of professional experience. I was working both as a .NET developer and a QA automation engineer. I've been involved in creating multiple automation frameworks in different programming languages, mainly in C# and Python, and I've been working with Cyclum for about 2 years now. And so what's the agenda for today? So today we're going to start from how to choose what to automate. We're going to discuss why focusing on progressive tests is more valuable than covering regression. I'm going to explain what progressive tests are later, so don't worry. Also, why is it important to involve developers in automation projects? How to ensure proper test isolation? Why you shouldn't invest in better logging? Why you should invest in better logging instead of relying on debugging? How to deal with flaky tests and keep the test pipeline green? Why you shouldn't just ignore test cases when bugs are opened? And how you can speed up your tests using different methods such as parallelization, API usage, or Selenium Grid. Alright, so first of all, let's talk about how to choose what to automate. Before we talk about that, let's ask ourselves this question: why automate at all? So the main reason why we use automation in IT projects is to reduce costs of software development, and we achieve that in two separate ways. First of all, we reduce an amount of manual time and effort needed to test something, and this allows us to release software much faster because, of course, automated tests are much more faster than a human, which would be doing the same tests, and it's much cheaper, of course, once it's implemented. And also it allows us to add new features or refactor our code much more easily because we're not so worried about breaking something, because we have a kind of a safety net from automation tests, which provide us much more confidence to release new features because we get a very fast feedback whether something is broken or not. If we didn't have automation, it would take a lot of time to verify it manually, or we would have to go on faith, which is, of course, not a good approach. So let's say we agreed that automation brings value to our project. We want to introduce it. But how can we choose what we should automate? Because we cannot automate everything, as you probably know. So there are several criteria which we should consider while we're thinking about this topic. So first of all, this is the business value of a given component of functionality. So how valuable is this functionality for the client or for the end users, how much revenue it brings. And usually, of course, the more business value something has, the more sense it makes to invest in automation on this area. Then we have to consider how often is this functionality changing. Is it being actively developed? Because it can be something which is very important, but also it can be implemented a long time ago and no one's changing this core functionality. So then we need to take this into account as well. And also we need to think about where the most bugs are reported. And this could also give us an indication of the areas of application which would benefit the most from automation. In a general case, usually most automation projects should start from a so-called sanity suite, or some people call it smoke suite. They're a bit different, but I will not go into this discussion right now. But basically, this is just a set of tests which verify that the basic flow of application is working. So they don't test in too much detail, and they basically kind of go over the most important and basic functionality of the application. So there is no arguments there. It's pretty obvious. But what is next, right? We're starting from the sanity suit, but what should we be working on next? And there are two main approaches after creating the sanity suit. So if the application is already existing and we want to cover it with automation, there are these two approaches. Approach number one, we can start by covering, after sanity suit, we can cover regression, which is basically writing tests for functionality which is already developed. And this is a very, very common approach, especially in UI testing, and I see it a lot. It's kind of standard, let's say. And the second approach is progressive testing. So progressive testing is writing tests for functionality which is currently under development. And I would like to convince you that actually the second approach is much, much better than first approach in pretty much most cases. So let's talk about progressive testing. So before we talk about progressive testing, let's discuss the most common approach, which is working on regression, and why it is less than optimal. First of all, development doesn't stand still. So while you're working on regression and covering it with automation tests, more and more features are added, which will need to be automated at some point. And it's very unlikely that we will ever catch up. So always there will be a number of features which are coming in and a number of features which we are covering in regression, and usually this gap never closes, unless the project is simple or there are a lot of QAs there. Also, while working on regression, you need to ask yourself, where do you expect to find most bugs, the most amount of bugs? Either it will be in the parts of application which are already released and working, or in the parts which are actively under development. And I think the answer is quite obvious. Also, usually how it looks like in the projects when we're working on regression, there were some manual test cases created for the old functionality because it had to be released, it had to be tested somehow. There was no automation at that point. So that functionality is probably tested by some manual test cases. And once we're starting automating it, we'll have to go to those manual test cases and try to automate them. But probably from experience, you already know that most of these test cases are written poorly for automation. And they're written with a human in mind. And even that application area may not be very suitable for automation. So for example, when it was implemented, no one thought about adding any automation IDs because it was tested manually, right? Also, there may be some minor bugs which can prevent you from automating a feature, and they will not likely to be fixed quickly. So once we're working on regression, we pick up something which was already implemented some time ago. It may have some minor bugs which don't have a big impact for the end user. For example, it prevents automation from working properly. It can be some bug like a pop-up which automation cannot handle or something like that. And usually it will not be fixed quickly even if you report it, because someone has to do context switch, bring it to the sprint, etc. And you know how it goes. Also, the last point, which is very important, but unfortunately it's not talked about as often as it should be. There's a huge lack of good teamwork between developers and automation QAs. So once developers are working on their own thing and automation testers on unrelated stuff, usually there's not any good communication, not any good teamwork, basically simply because people are working on different things. And this is a very important point which we have to consider. So to sum it up, any real value from regression testing is significantly delayed. Let's discuss progressive testing. So another approach which we can take is that tests are part of definition of done of a user story. So we do not close any stories unless it's covered by automation tests. And this is the approach of so-called progressive testing. So why is it such a good idea to do that instead of focusing on regression? So first of all, it enforces good design and testability from a start. This is a very important point, and people tend to forget about it, but tests also influence an architecture and design of an application. You probably know this from unit testing. So if you have spaghetti code, you don't have any interfaces, you have everything mixed up, you don't have clear separation of dependencies and injection, you will not be able to write any good unit tests because you will not be able to mock parts of code. You will not be able to isolate parts of code properly. So the mere existence of unit tests, it influences code design in a very good way because it forces you to think about better design so you can test it better, so you can write good tests. But the same kind of approach, it works on all level of testing, even on a more higher level of testing. So, for example, if your application is a monolith and it's very hard to isolate parts of it and to test them in isolation, it will show you in your tests that basically your application doesn't have very good design and it's hard to test it. It's hard to isolate it, test in isolation, it's hard to inject something. And if you find this out later, once the application is already developed and those parts of application are already released, no one's gonna go back and change the design. But if you're working on tests at the same time as it is being developed, there's much better chance that some kind of decisions which would enforce better design would be applied, right? And this is a great point, and I think it's rarely talked about. The second point, it's much better cooperation between developers and automation QAs. And any minor issues that may have prevented you from automating something will be fixed immediately, because anything you report, it will be reported under the story which is under active development, and pretty much no one has to do any context switching, and it's part of the sprint work, so there's a very big chance that any issues you encounter in automation will be fixed pretty much immediately. Also, of course, such approach gives us much more confidence in our newly released features, because they are considered done only when fully covered by automation. So we may have some technical debt, some features which were released without automation, but at least we know that from this point going forward, we will not accumulate any more technical debt, and it will always remain static. And of course, we can shorten it, we can work on it, but we know that after this point, everything comes out covered in automation, and it gives us a lot more confidence. The next point is that we waste no time trying to understand old manual test cases, which are not probably written with automation in mind. We don't have to read them, we don't have to try to split them, because usually they're huge, they contain like 5 or 10 test cases in one. We don't need to go to the talk to the QA and try to make him explain what he meant there, etc. So already once the story is being developed, any test cases are written with automation in mind, and we encounter no such problems. The next point is also very important, and this is that the testing pyramid is properly used. So you're probably aware about the testing pyramid, that the higher level of tests we do, so for example UI tests or end-to-end tests, the less of them it should be, because they're quite slow, they're unstable, and they take a lot of time. And if you don't work with developers on the same features in the same time, how can you enforce this testing pyramid? You basically can't. If you work with developers closely during development, you can even decide which test cases will be covered on unit testing level and written by developer, and which test cases will be covered on a higher level, for example, UI automation or API automation. And this allows you actually to follow the testing pyramid and make sure that this balance is being kept. But if you just go on and start working on the story which is already released, you can ask developer to go back and write a unit test for something he did a long time ago, but my intuition tells me that it's not going to be very likely that he's going to be happy with your request. And another point is that manual testers could be freed to do more exploratory testing or take part in definition of requirements, basically, or they can help create these test cases, but they can be freed up to do more meaningful work for them while we're covering automation, while we're releasing features covered by automation. So of course it's not either or. So of course we cannot leave regression entirely. So an ideal scenario would be a balance between working on progression and regression, of course prioritizing progression. But even if there's no time left to work on regression at all, I would still recommend to work on progression only. with a plan of involving developers in automation project at some point in the future. And which brings us to the next topic, which is why it's important to involve developers in automation testing. Why is it important to involve developers in automation testing? So before we talk about that, I would like to mention an important point about using a common programming language for both automation and development. So in practice, unfortunately, I've met a lot of cases where test managers decide to pick a different programming language for automation, citing different reasons. For example, it's easier to write tests in Python, or it's easier to find testers in some language. And they think that this way they're gonna save some costs, or they're gonna make it easier for automation. But unfortunately, most of them don't know that most of the time they're shooting themselves in the leg. This is not a good approach, and the best practice is actually to choose the same programming language for automation, the ones which developers are using, or in which the application backend is written on. And this has a number of reasons. So if you use the same programming language, developers can participate in common code reviews for automation as well. You can share knowledge between each other this way. Developers can also participate in writing automated tests. So we're going to discuss in the next few slides why is it important, but I just want to mention here that if you pick a different programming language for automation, it's a basically fail from the beginning. There's very little chance that you can involve developers in writing tests for you, because most of them will not be familiar with the technology you're using. If it's a different programming language, no one would want to install another IDE to learn the language just so he can write some tests. So this, if we're using the common language, it makes it much higher chance that developers can be involved. Also, we can reuse some stuff between projects, such as common models, some packages, some DB models, some classes. So if you're working within the same, basically, programming language, we can share a lot of stuff together. And also, another point is that developers can run tests locally easily without installing any additional IDEs. So if it's Visual Studio and developers write in C#, your tests in C# as well, basically for developer it's no problem to open your tests and run them from the same IDE. Of course, if we're using the same language. So we've discussed that. Let's discuss what are the benefits of collaboration between developers and QAs, and why it is very important we make that happen. So first of all, developers can run tests locally, even before waiting for CI. For example, for quick validation or debugging, usually when you report some bug, the developer has to reproduce it. And if a developer is involved in automation, he knows how to run tests, he is familiar with them. It's very easy for him, for example, to run this test and debug the application locally. Or, for example, he did some quick change, he wants to test it before it goes to the CI, for example, run a subset of tests locally, he can also easily do that. Also, this dev and QA collaboration, it reinforces good teamwork, and it allows us to share the best practices, especially for having code reviews. It enforces actual usage of testing pyramid. We've already discussed that. This way we are not over-testing on a higher level, and just to remind you, a developer can cover some test cases on unit test or integration test level, and you actually communicate and you have a good picture of what is covered where. And also, of course, developers can help out with writing tests when they have capacities, for example, when QAs are overloaded, or if you agree that developers can take care of progression, it can also be a way. So remember this problem we discussed previously, that what to do if automation QAs, they don't have enough time and capacity to cover regression and work on both progression and regression at the same time. So this is a solution. So developers can be involved to work on progression testing, and QAs in such case can go back and cover the regression. Of course, developers will be supervised by QAs and the test cases will be prepared by QAs, but the actual implementation of progressive tests, it can be done by developers. So the ideal outcome in such a situation, you build trust and good teamwork in your team. Developers also take ownership of automation, so this is not just a property of automation team, but of the whole team. So this way the whole team can work as one and contribute to automation. And basically both developers and testers can write tests. And I would like to say that if your project gets to this place, of course it will require time and effort, the success is almost guaranteed. Okay, so we discussed that in order for your team and especially developers to start working on automation, the whole team needs to have trust in automation, that it brings value. And in order to establish trust in automation, automation needs to be reliable, so it needs to have consistent results. It needs to bring us value to the whole team, such as finding defects, giving us more confidence for refactoring, giving us a shorter release time, etc. It needs to be run regularly to bring this value and to show it. But of course, in order to bring this value, automation needs to be reliable, to be trustworthy. So let's discuss how we can make it happen so. Which brings us to the point of test isolation. So in my experience, about 90% of cases of tests being unreliable is caused by improper test isolation. So what does it mean? It means that we're sharing test data. For example, we're using the same test data by multiple tests, which are being used by the tests. It's being modified in some unexpected ways, and this causes some instability. Other ways it can happen is that we are not using separate accounts or test environments for automation. We might not be also cleaning up data properly after tests. God forbid we rely on order of test execution. And for example, we may not be properly isolating our APIs, for example, in a microservices architecture. So let's see an example of test isolation. Actually, it's an example of incorrect test isolation. So this is an example of test written in SpecFlow. This is Gherkin syntax. And let's say we have a simple scenario that after login, our user navigates to the shopping cart, he adds a product and checks out an order. So in our given step, we log in using this email, we add some existing product to the cart, let's say Sony headphones. User checks out and pays with 100 loyalty points. Then we verify that the checkout is successful. The total price of an order is $100, and the user order history has one order with title of this product, Sony MDR headphones. So at the first glance, it may seem okay, but let's consider, is it really a good approach for testing? So first of all, what will happen if another test changes the price of the Sony headphones while our test is running? Well, of course, it's gonna fail because the total price will be different. Let's say what if another test creates an order for the same user? Then, of course, the order history will have more than one order and the test will fail. What if in configuration someone disables payment with loyalty points for a given user? Of course, the test is gonna fail because we are paying with loyalty points. And what if loyalty points conversion in a system is changed? Or what if the same test, in the simplest case, what if we run the same test twice? Will it pass again? It will not. If we don't do any cleanup, basically the test will not be passing because we may not have sufficient balance of loyalty points, or we may have a different order history, etc. So basically, on one very simple test case, we see that there are a huge amount of ways it can go wrong if we're not considering test isolation. So what is proper test isolation? So basically, you should always aim to create unique test data from the very beginning. So use unique accounts or users for automation. Don't use any existing entities, so for example products, which are already existing in the system. Always try to create a unique set of data for each test. Of course, where possible, this is a holy grail. If tests rely on some configuration, so for example, in the previous example, we had the loyalty points payment, inject it at runtime before the test is run. And of course, clean up your data. So you can clean up the whole database of the test run. You can clean up by some IDs. You can use rollback. There are many different ways to do that, but the concept is the same. And let's go back to the same test, but now we will properly isolate it, and let's see how it looks. So before test run, what we would like to do is we would like to create a unique user. So we'll create a unique user for this email, for this test. We will also want to create a product. It's also specifically for this test. So this will be our headphones. Then before the test, what we would like to do is we would like to set up this user, create this user, a unique one we created, and we want him to have 100 loyalty points. So we set it up as well. We set up this product with price 100, exactly what we expect in the test. We also set up loyalty points conversion. So one loyalty point is $1. So if someone changes this conversion, the test won't fail. And also we enable loyalty points payment for this user, for the user we created. And actually the test looks pretty much similar, but of course we use our unique test data. And after the test, we clean up our user and we clean up our product. So now with such approach, even if we consider all those points we discussed before, now if anyone changes the price of any existing product, if anyone changes any user or changes some configuration, it will never affect us because all of the data is unique for our test. We make sure that we inject all the configuration we need at runtime or before the test is run. And after the test run, we don't leave anything behind, so it will not influence any other test. So you can see that how, by just knowing about proper test isolation, of course we cannot predict every way that the test will fail, but if we have this in mind from the very beginning, we can design a test case in such a way that most of the issues we couldn't even predict or expect are already covered with this approach. So something extraordinary has to happen for this test to fail, and this way this gives us a very, very good isolation, and this test will be much more reliable. So another way we can achieve proper test isolation in this case for actually testing APIs is something called service virtualization. So especially if you're testing microservices, you should aim to test your services in isolation, and all of the external dependencies of the service should be mocked. So we're testing just the service we want. So in the case of service virtualization, let's see this example of system under test. And for example, our service, for example, it uses lots of external dependencies. For example, some other systems. It can be some other service, it can be service which we are developing, or some companies, some other third parties developing. Doesn't matter. There are free tools and ready-to-use tools such as WireMock, which allows you to mock all your external dependencies, and this makes sure that we have complete control over our application which we're testing, and this makes sure that we're not depending on any other external services or applications and any changes in their behavior. So for most of the functional tests, we want to test only our service. And let's say, for example, we have some external weather service or payment system which we're calling. So if we would not be using service virtualization, we would have to call this real payment system, or I don't know, even if it's a test system, still we don't have complete control over it. But in using service virtualization, it allows us to create mocks of our dependencies and completely control them from tests. So for example, for this test, you would like the payment system to return success. You set it up in this mock, and it works as a real system, but returns what you expect it to. The same for some happy path, unhappy path, etc. And of course, at some point we need to test real integration, but I would say it's at the very top of the test pyramid, and most of the business logic should be tested in isolation. So that's why we need to use such tools such as service virtualization. Another cool thing which can help your test automation framework is called test containers. So this is basically a library that it provides you the throwaway instances of common databases, Selenium web browsers, or anything else that can run in a Docker container. So basically, this allows you to have all the dependencies you need for tests, such as DB, to be set up from test itself, and to be spin up and cleaned up during the tests and after the test is run. So basically, I cannot cover it in full because there's not much time, but I highly suggest you to Google it, and it's a very cool solution. We've been using it in our project right now, and basically it allows us, usually when a tester needs to run tests, he needs to set up the whole local environment, right? We need to set up the DB, local DB, we need to set up, for example, some web browsers, we need to set up some message transport systems such as RabbitMQ, etc. But using test containers, you define from the test itself what the dependencies your tests have. For example, these tests rely on SQL database, and actually the tests themselves, once you click run, they will create this instance of the database in Docker. They will run all the needed migrations on it, and after the test is finished, it will just clean up this DB. So this allows you to have like a completely self-contained test environments either locally or on your CI, and I highly suggest to check it out. It's a very cool solution. It has versions for both Java and .NET, and probably some other languages, but I'm familiar of those two. So it's quite popular. Another thing that I feel I should mention, actually I feel I shouldn't mention it, but from my experience, unfortunately, I still see this happening. You should never rely on the order of tests. So each test should be completely isolated and run in complete isolation. And a good way to check whether your tests are properly isolated is to run them in parallel, and they should still pass. So if you have good test isolation, your test will still pass in parallel. If you don't, or and God forbid you rely on the ordering of tests, it will not happen. And of course, it's ideal to use a separate test environment for our tests, or to use completely isolated environment such as test containers if possible. Ideally, we should have this, but of course, even if it's not possible, let's say there are some budget restrictions or there's some other reason why you cannot have a separate test environment just for automation. Even if that's the case, I would say that with proper test isolation, it still should be feasible to have stable tests. So even if some manual testers will go and change something in the same environment which you're using, if you inject everything from tests as we discussed before, none of these changes should really influence your tests. Okay, so now we've made our tests very stable. We running them on CI, and we want the CI to be passing, and we want to keep this pipeline green. And why is that? So of course, reliable tests, they tremendously help to build trust in automation. So okay, so we made our tests stable. We want to run them on CI, on our continuous integration pipeline, and we want to keep the pipeline green. Why is that? So why should you aim to keep the pipeline green as much as possible? So the reliable tests, they help tremendously to build trust in automation, and the test should fail only on actual defects or changes, not on some test instability. And if the pipeline is read constantly, if it's failing, and it's failing not for a good reason, no one will bother checking it. So in some time, people will start losing faith in automation. For example, if your tests are always failing for some, environment issues, some test instability, etc., and then people will stop checking it because they will be tired of this. You expect some defect, you expect something meaningful, but then it's just instability. So our job as an automation engineer is to make sure that our pipeline is always green, and it's read only on some defects or changes. And this way, it allows to build much more trust in automation, and our tests will act as a signal that something has gone wrong, and we want this signal to be reliable. We don't want it to throw in false alarms all the time. That's not the point of automation. Of course, once the pipeline actually fails, the pipeline may fail for a valid reason, right? There can be some real change or some defect and tests are failing. But when you try to investigate what has happened, please don't rely just on debugging. So usually what happens is, what I see people do, they just try to debug test failures and fix them. That's it. They don't do anything else. That might sound like reasonable. Of course, what else should you do? But I'll explain in a moment. But let me say why relying only on debugging the failures is not the best approach. First of all, not all issues are reproducible in a local environment. Let's say some tests fails on the pipeline, but it doesn't fail locally. And then debugging won't help you much, because you debug it locally, everything works, right? But even let's say if you can reproduce it by debugging locally, after such a debugging session, all the knowledge is lost. So any other person which will have to go back to this test and check it again, he'll have to go through the same process, and there's no knowledge share at all. So what should you do? So instead of relying on debugging, you should first of all invest in good error reporting. What does it mean? You should write good assertions with a lot of details, and you should add as much logging in code as possible, especially after we had a debugging session and investigating some failure. So what I mean is that what I mean by that is that don't just debug it, but try to figure out what was preventing you to figure out what was the reason of the failure before you started debugging. So usually this means that the assertions or the logs which you have from the test are not enough. So ideally, you should just see on the failure in CI and be able to understand what went wrong, what was the expected, what was actual, where is the difference, and what could be the reason for failure, right? So that's why you need to add as much of good logging in code as possible. So then if the same test fails again, you will be able to see better what went wrong. So let's start with assertions. So what are good assertions? So basically, assertions should contain as much information as possible and anything that can help you with an investigation later. So let's look at a simple example. It's for the previous test. So the bad assertion would be like order type should be order type loyalty points, and that's all. We don't know anything else, and that's the whole assertion. An example of a good assertion would be, for loyalty points order, a price should be displayed in the loyalty points, and we display some information about the order. So this way, when we go to the test, we can actually see what was the order details, and its order ID, etc. And this will help us with investigation later. So this is kind of a very simple example, but it illustrates the point that we should add as much information as possible, even trying to output the whole like objects we're trying to validate, and which may help us to investigate what went wrong. Also, another important point is that you should add good logging in code, not only assertions. So I will show you a code snippet from our current project, which we use in SpecFlow. We added a method called wrap test failure. So basically what it does, so after any failure which happens in the test, it will go to the DB and extract all the logs for DB, from DB for this, for example, order or anything, any object we're trying to validate against. And here, for example, we are getting event logs and messages from DB for ID, for such ID, and we get this and we display it. And why do we need it? So basically this way, once the test fails on CI, you go open the test, you don't have to go to DB. Maybe it's already cleaned up, right? You don't need to check anything else. You have basically all the information, all the logs and reports you need on the test output, and you don't have to go and check any other place. So this can be also another example of good logging. Basically, you would want, going back to that point with debugging, you would want to, anytime you debug on a failure, you have to ask yourself, what prevented me from, what made me do this debugging, right? What was I missing in logs? So I didn't have to go and debug the code. So what was I missing so I could go and see what was the reason of test failure? So every time you debug, I would suggest you ask yourself this question. And if you see anywhere you can improve either assertions or logging or add something more, please do it. And this way the debugging sessions will be meaningful and not just being a waste of time and basically no knowledge share at all. And also, don't let tests fail due to known bugs. So even if a test is failing due to a known defect, don't let it to continue to fail. So please remember that automation pipeline should be always kept green. We've already discussed that, and it should only fail when we discover something new, some new issues or breaking changes. So if there's a known bug, never say, for some reason I still hear this, yes, the pipeline is failed due to known bugs. There's a bug, this and this and this. If you know that there is a bug, please ignore that test and make sure that anything else new that fails, it will inform us about some new changes, but we never want to see a known bug failure. But don't just blindly ignore tests. So usually what people do when they're going in the right direction, right? They don't want the test to fail and basically to send wrong signals to the team. But they just put a ignore attribute and then they forget about this test. And even if this defect is fixed, maybe there's a chance people will forget to go back and uncomment this ignore, etc. So what can you do then? I would suggest you use some solution for integrating with your issue tracking software. So for example, there is something for Python, which is called PyTest Jira. It allows you to mark your test cases with this attribute, with Jira ID number, and you can specify whether you want to run your test or not. So basically, in this example, we link a defect, and until this defect is fixed, so until it has some defined status such as closed or resolved, our test will not run. The moment it's been closed or fixed, the test will start executing again. And this way you don't have to remember about going back and uncommenting these tests or to check whether the defect was fixed. It will do it all for you. So this is a cool trick I suggest you can use in your project. Okay, so we've made our tests reliable, but now let's say we have a lot of tests and we're not happy with execution speed. The project keeps growing, the amount of tests keeps growing as well, and the time it takes to execute them is growing. So we might start thinking about speeding up our tests. Before we talk about the strategies for speeding up our test execution, I would like to remind you about test pyramid again. So first of all, ask yourself this question: am I over-testing? So maybe it's not a problem of the tests take too long time. Maybe the problem is you're testing too much on the high level. So you have too many UI tests when you can have much more, for example, integration or API tests and unit tests and have the same coverage. So first of all, the first thing I would like to mention always when talking about testing speed is this, because unfortunately I see very often that people try to solve it in some technical way, do some optimization improvements, when from the ground up they took the wrong approach and they have like 2000 UI tests completely unnecessarily, when like half or even more of those test cases could be covered lower. But no one of course thought about this, so you need to maintain a huge number of UI tests. And the mistake was not some performance issue or some technical issue, it's the approach issue. So this is why I always start discussions about test speed from this. But let's say, okay, you follow correctly the testing pyramid, you have the correct proportions and balance of tests, but still you would like to speed them up. So what can we do then? I would always suggest to enable test parallelization from the start. You should enable it from the very beginning because, of course, it will make tests run faster, but also it will enforce test isolation early. And because if something runs in parallel, if something passes when run sequentially, but is not passing when it's run in parallel, you have some dependencies between tests. That's basically a fact. And even if you have not very big amount of tests, when you enable parallelization, it will allow you to catch this very early and you won't have to do a lot of changes. But if you wait too long to enable parallelization, let's say you already have like 500 tests and then you decide, okay, I want to parallelize them. Unfortunately, you may need a lot of refactoring, and you'll probably uncover some issues which you haven't thought about before. And you have 500 tests, you have a framework already built, and it will be very hard to change them. It will take a lot of time. But if you enabled it right from the beginning, you will any new test cases which we add, and they will be written with parallelization in mind. So that's why I always recommend to enable it from the very beginning. So my rule is, once you have 2 tests, you should enable parallelization. That's like a golden rule, and I suggest to follow it, even if you think like, no, it's too early for that. It's never too early to enable parallelization, just trust me. So what are the options for parallelization? I would always suggest to start from built-in parallelization of your test runner, for example, NUnit or JUnit or whatever one you use. Let's take an example of NUnit, which is for .NET. It allows you to easily enable test parallelization just by using one attribute. You can define different scopes of parallelization. For example, you can have each test running in parallel, you can have fixtures running in parallel, you can have some specific tests which are running in parallel, etc. But basically any modern test runner provides built-in parallelization, and it's very easy to set it up. But it has, of course, some benefits and drawbacks. So the benefits is it's very easy and you don't need any additional infrastructure. But of course, the main drawback is that you're limited to the number of threads on your CPU. So if you have like 4 CPU threads or 8, the maximum amount of tests you will be running in parallel is 4 or 8. And therefore, it's not very scalable. So if you would like to run a huge number of tests in parallel, like 100 or even more, this is not possible with this approach, but usually from the beginning, for the beginning, it's enough, and then you can think about some more scaling. And when you will need to run a lot of tests in parallel, you can use some different solutions. I will just mention a few, such as Selenium Grid or Selenoid, which is basically the same idea, but is implemented in Docker containers. But Selenium Grid is basically allows you to route tests to different agents, different basically nodes. And each of those nodes will execute a specific subset of tests. And this way it's very scalable. You are limited by the number of nodes you can have and not just by your CPU. So this is an approach to take when you need to run a lot of tests in parallel. Another thing worth mentioning for speeding up tests is utilizing API in UI tests. So if you're working on UI tests, the main point is that you don't need to execute all of your actions in UI, which is obviously slow, if the test is not specifically validating that behavior. So let's say you are testing a checkout functionality, but before that you need to log in. But logging in through UI takes like 5 seconds, right? You need to open a browser, you need to input credentials, you need to click login. And let's say you have 200 tests for the shopping page. And for each of those tests, you're going in and logging in manually using basically Selenium. And even if it's just 5 seconds or 3 seconds, for 200 tests, it's a lot of time. So if you already have a test which tests login, you don't need to go and do it in UI all the time. You can just log in using an API. It will take you half a second. And this way you can speed up your test. And let's look at an example of the previous test we discussed during test isolation. So we have the same test where we want to add some product and check out the checkout is successful. But if you see our test, only our scenario validates the checkout functionality. So it doesn't care about login, it doesn't care about shopping cart, adding a product, etc. So we want to test everything after then. So this, of course, we want to keep in the UI because this is an UI test, right? But the logging and adding a product to the shopping cart, it can be done using an API. So for example, we can log in using some login API, we can add a product using some shopping cart API. This will take fractions of a second, and the actual actions which we need to check will be done using UI. And of course, all of this assumes that we already have some UI tests for the login and for adding a product. So this way we'll make sure it's already covered by one UI test, but any other UI test which uses the same functionality, it can use API. And you will be surprised how much time you can save using this, because a lot of tests have the same repetitive actions which are being repeated over multiple tests, and it's completely unnecessary. It just eats your time, and you can speed it up quite simply. And the last thing I would like to mention is to never use thread sleep. This is another thing that I was hoping I wouldn't have to mention, but believe it or not, I still see projects who use that heavily. So When you want to wait something, always use some specific waits. Never use blind thread sleep, because it will just sleep for amount of time you set it, and there's no reason to use it at all. Pretty much there's no maybe 0.1% of cases where you can use it, but most of the time please use specific waits, which will wait for something to happen and then it will stop waiting. And to conclude, today we discussed how to get the most value of your automation project. We discussed the common mistakes and the best practices for automation. We discussed how to choose what to automate, how to involve developers in your automation project and why is it important. We discussed how to make tests reliable, how to keep the pipeline green, and how to keep our tests fast and stable. So I hope this presentation was helpful for you and it will allow you to bring your automation game to the next level. Thank you for your attention, and if you have any questions, please ask them. Thank you.